Hi and welcome to Vulkan from Zero to Hero.
In this section, we are going to draw our first triangle.
In this video, we are going to create Vulkan device. Welcome back. In our previous video, we created Vulkan instance successfully. Before we start, it's better to make ourselves familiar with a brief description of some necessary Vulkan objects that we've been using. Instance is the first object we've created in our last video. It represents the connection between your application to Vulkan runtime. It works directly on GPU and stores all Vulkan states. Therefore, it is highly recommended to create it in the application as a static object. Device is the main object that is used to create all other Vulkan objects. Physical device represent a specific information for graphics cards such as vendor ID, device name, device ID, and supported features and properties by graphics device. By having Vulkan physical device, we can enumerate all available types of queue families. Physical device can also enumerate supported memory heaps and memory types. Now we've got GPU count, and let's allocate memory for array of physical device. If we fail to allocate memory, it's better to print out a message to the output again and call release function in order to release all the resources. We passed null pointer to vk enumerate physical devices as the third parameter because we just need to get the number of physical devices. Call vk enumerate physical devices again, but this time pass a pointer to array of physical devices as the third parameter. Let's iterate over all GPUs and create a Vulkan physical device properties for each GPU. If we couldn't allocate memory for device properties, then break from loop and set underline error to true value. Outside the loop, first check the value of underline error, and if it is true, then call release function. Now we want to create a shared graphics device for each GPU. Let's create a shared pointer for each device via std make shared. We need to declare a variable called vk underline physical underline device, which is a type of vk physical device. Now allocate the memory for device underline info, which contains information about current GPU device. Also, we need to store physical device features of current GPU. Okay, because we've stored device features of GPU in device class, so we don't need to release its pointer inside device info anymore. Now it's time to get Vulkan physical device features via vk get physical device features. First parameter is Vulkan physical device, and second parameter is a pointer to the Vulkan physical device features. Sometimes we need to set custom device features via application. Then it's better to add a W underline signal to device manager class in order to send signal to the application. Declare W underline signal in device manager.c++ with null pointer as default value. Now here, call signal in order to call callback from application. Define device underline info inside device class and also create physical device memory properties as another member of device class. Define a get_info function which returns custom device information string. We need to get memory properties from physical device via vk get physical device memory properties. Then we should get Q family property count. So call vk get physical device Q family properties with the following parameters. A Vulkan physical device, send Q family property count by reference, and finally send null pointer as a third parameter. We sent null pointer because we just need to get the count of Q family properties. In case that we couldn't find any Q, print out a message to the output. Assign true to underline error and break from loop. We want to store Q family properties inside the device class. So we need to define two vectors. One for storing vkQ family properties and the other one for storing Boolean values, which represents which one of these Qs supports the presenting mode. Let's define our Q and Q index in device class. We need graphics, compute, transfer, and sparse Qs. We are going to initialize them in Device Manager C++ file. Make sure to set default values for them in constructor on device class. You can get each queue via vk getPhysicalDeviceQFamilyProperties function. But this time, you have to send a pointer to the vector of QFamilyProperties. And after executing this line of code, we shall have QFamilyProperties data. After we've got data, we can iterate over these data and find the index of each queue by checking its flag. Do the same for all queues. And remember, graphics queue and present queue are the same, and we can remove present queue safely and just use graphics queue in our project. After you get each queue index, now you need to create a queue info. Set queue count to 1 because we want to create one queue, and the queue family index should be 0. And finally add queue priorities, which we already defined it as an array which contains 1. Finally, time to create Vulkan device. First, we need to create a VK device create info. If we have any device extension, we should add them here. Now call VK create device function. The first parameter is Vulkan physical device. The second parameter is device create info. We don't need to have any callback for now, so we can send null pointer as our third parameter to it, and finally send a reference to Vulkan device as the final parameter. Make sure to check the return result of the function. Now I think everything is ready and we can run our code. Let's compile the code and wait to see the results. Okay, everything is fine, and as you can see here, we got the number of physical devices successfully because Vulkan device is created without any problem. Very nice. In the next video, we are going to create Windows surface.